All right, what is a radian? Until now, you have learned that angles are measured in degrees, but angles can also be measured in radians. Well, let's talk about what a radian is. First of all, we don't have to solve for d, just kidding on that. Let's take the circumference, c equals pi times diameter. So if I were to take the length of this diameter right here, and I were to take it and I could just wrap this piece, let's do it in a different color. Wow, maybe green. I was to take this length right here from here to here, and I wrap it around this way, it's going to hit somewhere in, I don't know, maybe like right in here. Let's do a highlighter. Highlighter, yellow. Let's say that this diameter would come around. Here's the first diameter, okay? It would come around this far. And the next diameter would maybe come in about, I don't know, about right here. It'd be a little closer to that line. Okay, so that would give us the second diameter. And then we do one more diameter, and it comes in about right here. Third diameter, highlight, come around this way, and it stops about there. Okay, so you're like, well, what has this got to do with anything? Doesn't it say that the circumference is equal to pi times d, and isn't pi roughly 3.14? So it's somewhere near 3 diameters. The circumference is a little more than 3 diameters. Well, look, here's the yellow one, the pink one, the blue one. It's a little more than 3 diameters. Now, I did a demonstration in class, but if you weren't here to see it, you didn't get to see that. So you're going to have to trust me on this. But try it on something at home. Find the diameter of a circle and trace the outside. Make that length going around that circle. See how many diameters you have, and see if you don't have this little bit of space left over. Well, what is that little space? It's the 0.14. So it's a little over a tenth. It's 14% of that diameter. What diameter? The one that goes all the way across here. Okay? Now, I'm going to get rid of this. How many diameters are in a circle? You're going, there's only one, or there's infinitely many. No, how many can go around a circle may have been a better word. Pi diameters. 3.14 of them will get around a circle with a few more decimals, as you well know. All right, so let's clean this up a little bit because I don't want it left there. That'll drive me crazy. All right, so how about half a circle with half a diameter? Well, half a diameter is the radius. So how many radiuses or radii would fit around half the circle? So in other words, if this was just the radius, let's take this yellow, and we took this yellow piece, the radius, and we go, okay, here's one radius. Here's the next radius. I'm going to try to make it about the same. And here's the last radius, trying to make them about the same. It would just be slightly shy of meeting that. It looks to me like with a radius and going half the circle, not the whole circle, half of it, we can get pi radiuses in there as well, or about 3.14. And you have this little section that didn't finish out. Wow, it looks a lot like the one before. So a radian is formed by an angle whose arc length is the same measurement of the radius of the circle. So if this is r, this distance is r, and this distance is r, this angle right here, that's a radian. And how many radians are in the top half of the circle? Well, there's pi radians in the top half of the circle, because we could do this 1, 2, with this next piece of pie going down here, and then the last one. And then we would have this little extra piece, that 14% of the radius is still left. Okay? So that's what a radian is. How many radians will fit on the circle? Well, about 6. In fact, to be exact, 2 pi of them. Or 6 6.28. That's about 6 1/3 radians that fit around, okay? All right, so let's look at the next one. All right, so this is the piece that I will finish out, and we'll stop after this, and then we'll talk about the angles and stuff. So let's keep going. This may be a little bit longer video. I'm already at a 5-minute mark, but I need to finish these radian measures. So we started radians, and let's look and see what we can figure out about them. Well, first of all, I have said that from 0 to over here to half the circle is pi, okay? And if we complete a full circle, it is 2 pi. Well, guess what? If this from 0 to here is, let me do this in a highlighter, a yellow highlighter. If from 0 all the way around half a circle is pi, what do you think this point is going to cause us to have? Da, 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 da. If you said pi over 2, you are correct, or half pi. So if this is 0, pi over 2, pi, we're going up by half pi each time. So what would 1 1/2 pi look like? Well, as a mixed fraction, it's 3 pi over 2. Okay? Now those numbers don't change. We still have 0, pi, and this side is 2 pi. Up here we still have pi over 2, and this is still 3 pi over 2. Okay? So now what we're going to do is we're going to talk about, and I hope this shows up. Oh, maybe this color will work. We'll see. I have split this in half with this piece that's right here, okay, with this one that I'm putting the little blue dots on. I've cut this in half again. Well, this is how far around between 0 and pi over 2. What's between 0 and 1/2? It is pi over 4, or 1/4 pi. So if we're at 0 pi over 4, 1 pi over 4, look at this. Is this the same as 2 pi over 4? Wouldn't that reduce to 1/2? Sure it would. 3 pi over 4, and it keeps going. This one would be the same as 4 pi over 4, but we would never write it that way because the 4 is reduced. That's kind of silly. 5 pi over 4, 6 pi over 4, and 7 pi over 4. So this one reduces, and it goes to this, and we would keep it as 3 pi over 2. Now the last one, to finish this off, this is no longer taking half of a half again. Now I will tell you what does not change is we have 0 and 2 pi, and then here we have pi, okay? That has not changed. So going in with this, let's see what we do have. So there are, let me use my orange. I'm going to show you there are 1, 2, 3 sections on this side, 3 on the other side. So this half is made up of about 6 equal sections. We're going to pretend my lines are perfect, and that is exactly 6 equal sections. So you should be able to figure out without too much work that this is 1/6 pi, or pi over 6. This one would be 2 pi's over 6, but 2 pi over 6 reduces to pi over 3. Well, the next one would be 3 pi over 6, but wait a minute, 3 pi over 6 would reduce to pi over 2. That did not change. That's just like it was over in the first one. The next one is going to be, it was 3 pi over 6 on this one. So this is 4 pi over 6. But that reduces to 2 pi over 3. And then 4 pi over 6 becomes 5 pi over 6 for the next one. And this last one would have been 6 pi over 6, but that would be silly because it reduces to just pi. Now what I did in class, and I'm going to do here, is I want to point out something really cool is happening. Can you see how we got a pi over 6 here and a 5 pi over 6 here? That is not a mistake. If you reflect this circle over the y-axis, you're going to get the same bottom number. That denominator is going to match. You see this one's matching as well. Let me see, that one's orange. Let's go to blue. This one is matching as well. See how it's matching? The denominators match. They're the thirds. I just want you to notice that. That's real important to catch. All right, so if you haven't done so, go ahead and finish this out. So we had 6 pi over 6, 7 pi over 6, 8 pi over 6, which is 4 pi over 3. And, oh, wait a minute, we've already got a number for this, 3 pi over 2. And then we were at 8 pi. This is 9 pi over 6, which reduces to 3 pi over 2. No, that can't be right. Oh, 9 pi over 6 was this one. And then we would have 10 pi over 6. That reduces to 5/3. This one should be 5 pi over, it divided by 2, 3. 5 pi over 3. Well, we were at 4 pi over 3, so there you go. And this one would be 11 pi over 6. This one would actually be 12 pi over 6, but 12 over 6 reduces to 2 pi, so that'd be kind of silly to write it that way. Now, did our rule keep up? If I reflect this downward, do you see how the thirds match again? If that's reflected over the y-axis, look, the thirds come back in again. Let's go back real quick. Did the 6th work out? Well, if this 6 up here is reflected down, there it is. And this one is reflected here from both across the x and the y-axis. Guys, it also happened with the fourths. Do you see all the fourths coming into place right here? Okay, they all did the same thing. So that's the end of that. Let's finish up this video as quickly as I can. I'm up to 10 minutes. Can you estimate where this picture is going to land, what this would be? Looking back at the one, kids guess this one to be either pi over 4 or pi over 6. And if this is pi over 6, just opposite that, that looks like it's on the opposite side of the y-axis. This would be 5 pi over 6. And then 7 pi over 6 is actually hitting in here. So this one's the 5 pi over 3. I think is it 4 pi over 3? Hold on. It's 4 pi over 3, my bad. Let's erase this. 4 pi over 3. We may have to look at the previous page to remember it. 4 pi over 3. I know 3 pi over 3 hits right here because this is pi. And so it's a third of the way around. So 4 pi over 3 should be right. Okay? Can you find these 3 and then we're caught up to where we were today in class? All right, so here's the initial angle. We need to do -3/4 pi. Well, remember, negative pi is right here, 0's here. 3/4 of the way around is about here. And we have to draw that arrow going this way. So this is -3/4 pi. 16, I don't know if you can see the little arrow here, but there it is. 16 pi over 3. Now I'm going to show you what to do with this one. We're going to do 16 divided by 3 equals, okay, 5.3 repeating. That means I have 5 1/3 pi's. So I'm going to do this, and this is positive, so I'm going to go this way. There's 1 pi. If I keep going, that's 2 pi. I'm not up there yet. I got to get to 5 of them. This is 3 pi. I'm going to do another one. 4 pi. And one more halfway around will give me 5 pi. Is 5 pi enough? Nope. I need 5 1/3 pi. So another third is going to put me coming out down here on the bottom. There is my 5 1/3 pi. All right, opens up here. In fact, it's really close to this fourth. It's just a little bit further down. Now this one, as I told the kids in class today, this one is a big evil. The evilness about this is pi is not part of this. So I can't just go, oh, it's over here at 2 pi, I'm done. It's the initial one. Instead, it just says 2 radians. No pi is involved. Well, we know that this is approximately 6.28, roughly. Okay? So 1 pi is approximately 3.14. So it's going to be somewhere in between 0 and 3.14. Well, 90 degrees, it's going to be half of pi. Remember, this was pi over 2. If we take 3.14 and we divide it, we get 1.57. So to get to 2, it's somewhere in between 1.57 and 3.14. This is 2 radians. That is mean. Mean, mean, mean. Okay. So, and we're stopping. Oh, no, I did this one too today. Dadgummit, I thought I was done. I'm sorry. One more quick one. All we have to do on this one, what's a full rotation in radian measure? Okay, so if we have pi over 2, that's taking us from here to here. That's pi over 2, okay? So what we're going to do in a full rotation, it's 2 pi. So to get coterminal angles with radian measure, it's going to be theta plus or minus 2 pi, okay? So find 2 coterminals. So what we're going to do is we're going to take pi over 2, and we're going to add 2 pi, and we're going to subtract 2 pi. So first one, we're going to go add 2 pi. Watch this in a calculator. So super easy. You hit that N over D button, and you're going to hit pi. Where's my pi? There it is. Pi over 2 plus 2 pi. Whoops, that's in the wrong place. Delete. Arrow over. Plus 2 pi. Enter. Now I want you to see that comes up 5 pi over 2. So one of the answers is 5 pi over 2. What your calculator has done is it knows that 2 is the same thing as 4/2 pi. And this is the same. This is just pi over 2. So if I add it, this is an understood 1 pi. So 1 plus 4 pi is a total of 5 pi over 2. Now, if we change this to a subtraction, you're going to get 1 pi minus 4 pi, which would give you negative 3 pi over 2. And if you plug it in your calculator, that's what it's doing for you. 3 pi over 2. There you go. So in the last one, you've got negative 4 pi over 5 plus 2 pi. Now think about this. 2 pi, I need it in fifths, so I need to double that. That would be 10 pi over 5, right? That reduces down to 2 pi. So negative 4 plus 10 pi is going to give you 6 pi over 5. 6 pi over 5. And if we have negative 4 minus 10 pi over 5 is negative 14 pi over 5. So those are your 2 answers. So negative 14 pi over 5 and 6 pi over 5. And I believe that's as far as we got, and kids went through 13. Now, if you're in an even class on Monday, we are going to finish this out, and I'll do that. on another video.